Okay, so now what happens after we have our graph? Then it asks us to find the symmetry, the zeros, and the maximum values. And so we really, to determine the symmetry, we already know that we have theta equals pi over 2. So it's symmetrical about that line. But it's also symmetrical about the polar axis. And it's obviously symmetrical about the pole too. And that's kind of if you have diagonal symmetry. You can kind of see that. If my graph been better, you could have been able to tell. But how do you tell without having graphed it? And so this is going to take you back. You're going to like this. One of the things it says is if we can replace r theta with either negative r theta, those are the same, or r, I don't know where the 2 came from, or r and pi plus theta. So we're going to test this out. So I know the original function is equal to r, which is 1/2 sine of 2 theta. If it's equal to 1/2, and I'm going to use the second one here, 1/2 sine of 2 times pi plus theta, then it's going to be symmetrical about the pole, which is just that center point there. So if you all remember proving identities, that's what we're doing here. This is an identity. And some of you guys are probably freaking out, but this is a good one. And so we're just going to go back over that. On the left side, we really can't do anything else. So I'm going to leave that as 1/2 sine of 2 theta. And then on the right side, we're going to distribute the 2 and get 2 pi plus 2 theta. Well, what this actually is right here is the sign of a sum. And so that's one of our identities, which is, remember, alpha plus beta. And that is sine of alpha cosine beta plus cosine alpha sine beta. So we're going to use that on the right side. So I want to see if that, what I have highlighted there, my little squiggle part, is that equal to sine 2 theta. So I have sine of 2 pi is going to be alpha cosine of 2 theta plus cosine of 2 pi sine 2 theta. Well, sine of 2 pi is 0, so this is just 0 times cosine of 2 theta, which is going to be 0, plus cosine of 2 pi is 1 times the sine of 2 theta. So we end up with 0 plus sine of 2 theta, which is just the sine of 2 theta. So the part that we have in the squiggle, this part right here, is equal to the sine of 2 theta, which means that they are equal to each other. So 1/2 sine of 2 theta on the left is equal to 1/2 sine of 2 theta on the right, which means that for our symmetry, it has pole symmetry, which we just proved there. It has polar axis symmetry, which is where it's our positive x-axis. And it also has symmetry about theta equals, let's back up just a little bit, pi over 2, not 2 pi. So there's our symmetry. And then It also wanted to know what are the zeros. Well, the zeros are the same that we had over here. We have zeros at 0. And pi over 2 and pi. And 3 pi over 2. And then back at 2 pi. And then our max values. We're at 1/2. All right, that is all, and we're going to have some practice here in just a little bit.